thing here. Again, that's what we have in the sense of the permutation, which is the order matter. If you look at C, which is the combination, because the order is not matter, right? The order does not matter. And if the order does not matter, this is what you need to do, which is the phi C2. So your challenge is you need to ask yourself, is, do I using the NPR or the NCR? Because again, if the order matter, we will use the permutation, which is the NPR. And in this case, the order does not matter. So I use the NCR. And as you can see, the NCR is basically is equal to 10. So in this case, everybody see that this is what I have is I only have 10 if the order does not matter, and I have 20 if the order matter. Okay, and let's take a look at another one, which is, let's take a look at this item here, and I can show you the actual item we have similar to A. They tell you that suppose that you want to choose 2 letters without replacement from the 3 letters A, B, and C. How many ways can this be done if the order of choice matter? So the order matter, so if the order matter, if the order is important, we know that we need to use permutation. And if you use permutation, this is what you guys should have, which is 6. And take a look at this, ladies and gentlemen. And let's say why the order matter, we have 6. Do you agree that if the order matter AB is different from BA, and vice versa, AC is different from CA, and lastly, BC is different from CB? So everybody see that each letter, this is what they ask you, right? You have 3 letters, A, B, and C, and you want to choose 2 of them where the order matter, meaning the first item is different from the second item. And again, in this case, everybody see that I have 6 individual items. I have A, B, and BA, which is A is important than B, and B is important than A. Okay, and vice versa, if you look at B, if the order doesn't matter, meaning this is my combination, which is the 3C2, and the combination 3C2, there's only 3. Why there's only 3? Well, if the order doesn't matter, everybody see that A and B is only one object. A and B, if the order doesn't matter A come first or B come first, it's just A and B. Those are my item. A and C and A, that is my item. It doesn't matter who comes first. And lastly, B and C or C and B, those are my item. As you can see, those are my individual 3 items I have. Okay, so the difference between permutation and the reason why I can use this, because again, we don't have that much item to list out, right? A, B, B, A, those are, if the order matter, those are 2 individual items. But if the order doesn't matter, A and B and B and A is just the same. Okay, A, C, and CA, if the order matter, that's 2. But if the order doesn't matter, it's only 1 item. And vice versa, B, C, and CB, if the order matter, that's 2 individual. But if it does not matter, there's only 1 item. Okay, so that's what we have in the sense of the permutation and the combination. And if you have a calculator, like I say, if you have a calculator, you can type this thing in very, very doable, right? You just type in 3, you go to the PRB, and then you choose in the NCR or the NPR or NCR. And in terms of this thing here, that's where I get 6. And vice versa, you type in 3, you go to the NCR and you write 2, which is, that's where I have 3. So the calculation is doable. The hardest problem is, which one am I using, right? Am I using the NCR or the NPR? And that is your challenge, okay? And as you will see, in this problem, let's take a look at this problem, and then I will ask you guys if you have questions, right? So make sure, make sure that this is what we have. We know that we need to choose 5 items from a group of 14. So we know that n is equal to 14, and we need to choose 5 of them. How many ways can this be done if the order of choice is taken in consideration? Again, they just changing the word, but if you take it in consideration, meaning the order is important, meaning the order matter. And if the order matter, what do? Well, all we need to do is we need to use the NPR. And the NPR meaning, again, what is my N? My N is 14, the total letter. The R is my 5. And like I mentioned earlier to you guys, if you have 2 numbers, in this case, we have 5 and the 14. If you have 2 numbers, the bigger number will always be your N, because you cannot choose 14 if you have only 5 items. You can choose 5 items from a group of 14, but you cannot choose 14 from a group of 5. Okay, so the N will always be your larger number, and the R will always be your smaller number. And if you do this thing here again, right? If you do this thing here, we know that we're using the 14, the NPR, and 5. So if you do this thing here, you have 240,240 different ways to do it. Okay, and if you do the 14, the NCR, if you do the 14 NCR and 5, you can see that you have only 2,002 different ways. And yes, ladies and gentlemen, if you have not recognized, if you have not identified it, the combination will always be smaller than the permutation. The combination will always be smaller than the permutation. When the order matter, you will always have more items, because they restricted in terms of which one comes first and which one comes second, and so on and so forth. If they don't restrict it, you will have less items. Okay, so again, let me ask you guys question. If you have a calculator, question on how to use your calculator, or question on how to determine if it's the NPR versus the NCR. All right. If you don't have question, let's take a look at what if they throw in the real life situation, right? So what happens if we have D? Yeah, they give you this thing here. And this is what I mentioned to my student a lot is, the challenge is not the math. This class, the math, as you can see, we always have some shortcut to do, some easy way to calculate the item. The challenge is the English, right? How can you take the English wording? How can you take the English wording and put it in your math, right? So if we take a look at A and you take a look at B, your goal, your objective is you have to decipher this problem and ask yourself, is it permutation or combination that I need to do? So in this case, for A, from a collection of 51 customers, 2 of them are choosing to receive a special gift. How many group of 2 customers are possible? Okay. And B, they say 73 athletes are running a race. A gold medal to give to the winner, a silver to be second place, the bronze will be in a third place finish. Assume that there are no tie. In how many ways can 3 medals be disputed? So look at this thing here. Hopefully you guys see that, well, we have a group of items and we need to choose some number, right? In the first one, we have 51 and we need to choose 2 of them to receive this prize or this gift. And in the second one, we have 71 of them, and we need to choose 3 of them to receive this medal. So one thing I tell my students when you do this thing here, or one thing I want to tell you guys is, ask yourself, do the two people in part A, do they have some specific order that we need to put? Is there specific ranking that we need to put in? Or do they have specific title that we need to put in? If you say no, they don't have any order, no, they don't have any specific ranking, and they don't have any specific title. The title is basically the president, vice president, secretary, treasurer, something in terms of CEO, manager, or CFO, or something like the position. Okay, that's the title I mentioned. Okay, so in terms of this thing here, as you can see in A, they don't give you the specific title or specific order of this 2 customer. All we know is, in general, I have 51 of them and I need to choose 2 of them. And if those are the general, then this is what we do. If they give you in general, you will give them combination. So if they just tell you, I have this group of people, form me 2 people or find me 2 people, doesn't matter what the order, doesn't matter what the ranking is, then that would be combination. And if for B, why is this permutation? Because hopefully you guys see that they have a specific ranking. We have first place, which is gold, second place, which is silver, and third place, which is bronze, meaning they have a different order that we need to put in, or we have specific ranking. And if there is some ranking involved, there are some ranking or some order involved, we will use permutation. And that is the biggest difference between combination versus permutation, is you have to determine, does the order matter? Do they give us anything that we need to put them in order, or they give us anything that we need to put them in some ranking involved? Okay, and again, looking at this thing here, like I mentioned, the calculation is not hard, right? If you can determine permutation versus combination, the calculation is not hard. You just say 51, the NPR, or in this case NCR, because it's a combination, which is 51 choosing 2, where the order does not matter, then 1,275. If we have 73 choosing 3, where the order matter, which is the permutation, which is again 73 choosing 3, the order matter, we have 373,176, right? So in this case, this is what we have. Like I say, the hardest part is to determine which one to use. Once you determine which one to use, the calculation is not that difficult. Question with D or C? And let's take a look at this item here. Let me ask you guys, if you read A and you read B, or let's do A first. If you read A, let me ask you guys, is this a permutation problem or combination problem?
Permutation?
Why?
Because it can't be repeated.
Well, both of them cannot be repeated. But why is this permutation and not combination?
Because the order matters.
Yes, because the order matter, right? Because let's say your password is A, B, C, D. Hopefully that's not your password, but let's say that your 4-letter password is A, B, C, D. It has to be that specific order in order for you to log in, right? You cannot put in DCBA and it's unlocked, right? Because of this password, in order for you to log into this computer, you have to put in the specific order of the letter that your password is, right? You know, your password, let's say you have ACE, right? Your password ACED, right? You cannot put in DACE because it won't work out, right? So in terms of this thing here, the permutation is the order matter because that is your password. Each letter, each position of the letter is important. So if you have that item, which is the determined permutation, you can see that we have 26. They told you that there are 26 letters, which is that is your total item you can choose. And how many are we choosing from 26, which is we choosing 4. Do you agree that we have 26P4 and YP because of permutation and Y permutation because the order of the word matter, right? And that's why it's permutation, okay? So again, that's your challenge for you guys. Your challenge for you guys is that how can you take this wording, all of this thing is start out with wording. How can you take that wording and decipher in terms of a permutation problem, the order matter, ranking matter, title, right? Or general combination. What about B? If you read B, we know that there are 13 and we're choosing 4, right? We have 13 city and we want to choose 4 of them. So we know that 13, 4. Is it permutation or combination?
Combination?
Combination.
Is it combination?
Combination, yes.
Does the CDC visit on Monday important? One thing is, remember, because you have to make a schedule. You know, I know you will say, well, they did not say that Monday is important than Tuesday, is important than Wednesday, and it's more important than Thursday. I know you say that there is no ranking involved in terms that the day are the same, but because you make a schedule, meaning there are some order, okay? Because that you make a schedule, your schedule have to have some order involved. You cannot, because of this item here, in terms of scheduling, there, you know, let's say she visit Paris on Monday. I agree with you that she don't visit Paris on Tuesday and she visit London on Tuesday, right? But in the sense that because you have to put them in a schedule, meaning schedule, there are some order involved. You cannot just go on Monday, you know, it's not like you have 4 cities and you can just visit any day, any city. Because you have to put them in order, that's why you have to use it as a permutation. Is that making sense? It's not it's not that you don't just go into any city on any day, right? That's not what they ask you or tell you right here. They tell you that she want to go one city on one day. And because she want to go in one city in one day, meaning she have to put in some scheduling. And if it's you schedule something, meaning there are some order involved. You cannot just put in Paris, London, Belgium. Well, Belgium is just Madrid, and I don't know what the other city is. Let's say you know you have that 4 city. You cannot just put in, oh, you can visit any given day, like in general, right? Because you have to schedule them, you have to plan the route, and you know, plan the route to make it effective. Then you have to make some order involved, you know, and that's where the permutation come in. Okay, so it's not is if they just tell you, if they don't tell you to schedule, if they change in this thing here and they say Nancy have 13 cities he want to visit and 4 of them. How many ways can he visit? If it's that general, then this would be combination. Okay. If they just say I have 13 cities and I want to visit 4 of them, doesn't matter which 4, I just want to visit 4 of them. How many ways can I do it? Then you would say, well, that's combination because it's in general. The difference between that problem I mentioned versus this problem is because you have to make a schedule. And the word schedule tell you that you have to put them in order. And because there's an order involved, there is a permutation. Is that making sense?
Yes.
Now, question. Question on those. Well, let's take a look at the, I think, let's see if I can do one more slide after this. So the last, well, not the last, the next thing that we want to go over, or I want to go over with you guys is, once you determine the combination and permutation, the next thing that you need to ask yourself is this item, ladies and gentlemen, is, do they give you a multiple item? And this is where they put everything together in terms that they want to put the combination or permutation together with the fundamental counting principle. And if you remember, the fundamental counting principle is they basically tell you that if we know the total of each individual group, all we need to do is take them and multiply them together. So if you look at this problem F and G, you will see that you have multiple groups. They ask you this question: a committee consists of 3 faculty members and 5 students to be formed. So whatever this committee is, you need to have 3 faculty and you need to have 5 students. Each committee position have the same duty and same vote. And again, that is very important, meaning each person in this committee are equally, they don't have any order, they don't have any ranking, they don't have any specific title, right? They all the same. There's no one more important than the other one. They have the same duty. There are 11 faculty members and there are 15 students who are eligible for to be served in this committee. In how many ways can this committee be formed? So one thing is, hopefully you recognize that we have 2 different groups. We have a faculty group and we have a student group. And because they tell us the order doesn't matter, we know that this is a combination problem. And if this is the combination problem, this is what you guys need to do, is you guys need to do the faculty group by themselves and a student group by themselves. You cannot add them together, and you cannot say we have 26 people and we choosing 8. If you do that, if you add the 11 and the 15 and the 3 and the 5, if you add that, you are not guaranteed that you have 3 faculty members and 5 students. If you say 26 choosing 8, you might have 8 students by themselves or 8 faculty by themselves. You are not guaranteed that you have 3 faculty and 5 students. In order for you to get guaranteed that you have 3 faculty, you have to find how many ways can you choose 3 faculty from a group of 11. And again, the order doesn't matter, so you have 11C3. And then you have to do the student by themselves, which is now I am guaranteed that I have 163 ways to choose 3 faculty from a group of 11, and I have 3,003 different ways to choose 5 students, 5 students from a group of 15 students. So this is what we need to do, is we need to do each of them separately. And once you have them, each of them separately, the fundamental counting principle come in place. The fundamental counting principle tell me that if I know that this much for the faculty and this much for the student, if I know in that much, all I need to do is take the 2 items and multiply them. And if I multiply them, the answer I get will be 495,495 different ways. Okay, so this is the difference between this problem versus the previous one, is because of our because they give us multiple category, we have to do each category by itself, and then at the end multiply them together. Okay, and that's what you need to do in terms of the G2. But one thing, you know, is like I mentioned, the hardest part is how do you decipher if it's a combination or a permutation? You know, in G, it's kind of very general. You know, 3 research departments have 8, 10, 7 members respectively. Each department to select a delegate and an alternate to represent the department at the conference. In how many ways can this be done? You know, if you glance through this thing here, you probably, you know, you look at this thing here, the first department, we have 8, we choosing 2. The second department, we have 8 choosing 2, 10 choosing 2, and the third department, we have 7 choosing 2. And you probably say, wait, Mr. Tran, why is this a permutation and not a combination, right? Why am I using permutation here and not combination? The reason is because they give you the delegate versus the alternate. Meaning, again, they give you specific ranking. It's not that we have to choose 2 in general. Like, you know, if they say we have 8 people and just I need 2, because again, if the alternate doesn't go to the conference, right, unless the delegate cannot make it, then the alternate will come in. You know, in the idea of the warden, right? In the idea of the warden, you have to see that they give you 2 different number, or not number, but 2 different position. You know, and I am not really sure of how to tell you guys this, but it's all the warden, all the English warden that tell you, and you have to decipher each of the warden, right? You know, like I mentioned right here, the first department, we have 8 people, we choosing 2, but because we need the delegate and then the alternate, again, the delegate, if he cannot make it, if he's sick, and the alternate will go, right? So basically, that's what we need to do. And, you know, in the sense, that's what we have is we need to find for the first department, for the second department, and the third department. And the only reason why I'm not using the C is because they tell us, they give us a specific title, right? If they tell you that you need a president and a vice president, that's your title. In this case, the title is the delegate and the alternate. And again, once you find for individual, all you need to do is multiply each of the department together, and this is how many ways you can mix and match them together. And again, 211,680 different ways that you can mix and match the item. Okay. Let me take a look at this item here. Let me list them out, and then let me explain each of them. Let's take a look at I first. I think I should do I before H, but I actually put H before I. So let me show you the item that we mentioned earlier in terms of the distinguished item that we have. So if you look at I, this is what they tell you is find the number of distinguished arrangement of the 12th letter in the word re-engineered, right? So in order for you to find a distinguished arrangement is basically tell you that you cannot have something repeated when they are identical, okay? So in order for you to do that, this is what they tell you to do is you need to take the N, the n is the total number of items you have, divided by each individual repeated item. Okay, so everybody see that my OR, basically again, how do you find a K1, K2, K3? Basically, you ask yourself how many individual items you have. So my OR, my individual OR, I have 2 OR, and that's where my number 2 comes from, is I have the OR here and the OR here. My E, I have 5 E, 5 individual E. My N, I have 2 of them. My G, I have only 1. My I have only 1. And my D, I have only 1. So individually, those are the items I have. I have 2 OR, 5 E, 2 N, 1 G, 1 I, 1 D. And if I add the individual 2 plus 5 plus 2 plus 1, that's 10, plus 1 plus 1, that's equal to 12. That is the 12th letter I have, right? So this is what they tell you is in order for you to find a distinguished arrangement, you take the total item, divide by each individual factorial. And again, you can find the factorial notation in your formula, or not in your formula, in your calculator. And you can take this item and divide it, okay? Similarly, on top, this is what they tell you is Joe want to arrange 12 cans in a shell. And again, we want to have a distinguished item, right? They have to be distinguished order. So what do we have? There are 4 bean, 5 corn, and 1 pea, right? So looking at this thing here, as you can see, 4, 7, and 1, that together is 12. So all we need to do is take the total, divide by the individual repeated item. And if you do that, or if you were to want to, using your calculator, you can see that this is all you're doing is you take in 12 divided by, make sure, not 12 factorial, and to find the factorial, this is what you need to do is you hit the mat, P or B, and go to number 4, and that is where your factorial is. Everybody see that mat, scroll over to B or B, and option number 4, that's where your factorial. So I have this item, 12 factorial, divided by, make sure you need to, this is the most important thing I want to tell you guys, on the denominator, make sure you put in the parenthesis. Make sure you put in parenthesis, which is 12 factorial divided by open parenthesis, which is your parenthesis is here, 4 factorial times 7 factorial. And again, I don't have to do the 1, but you can see that I can do the 1 too. So again, 7 factorial, and then again, 1 factorial is just 1. So make sure that you put in the parentheses and close it, right? 1 factorial is just 1, so I don't need to put a factorial there. But this is what you guys need to do is make sure that you put in, if you just put 12 factorial, if you just put 12 factorial divided by if you put 12 factorial divided by 4 factorial and then multiply 7 factorial, is will tell you is wrong, because this thing here basically tell you, or you tell the calculator to take the 12 factorial divided by the 4 factorial, and then whatever that result is, multiply to the 7 factorial. Okay, so make sure that you, on the denominator, you need to put in the parenthesis. So 12 factorial open divided by open parenthesis, 4 factorial, 7 factorial, and then the 1 factorial. Do not put in 12 factorial divided by 4 factorial and multiply by 7 without the parenthesis. Because without the parenthesis, they will tell you, or the calculator will do this item first, which is division, and then they multiply whatever the last item is. Okay, so again, make sure to put in your parenthesis. But this is only a curve if they ask you to do the distinct arrangement. Okay, it's basically the total item divided by the individual item factorial. In terms of this thing here, the 4, the 7, the 1. This item, we have to identify how many repeated item, which is the all repeated by 2, the E repeated by 5, the N repeated 2, and the G is 1, the I is 1, and the D is 1. And you know, if they have the word Mississippi, the M is 1, the I is 4, the S is 4, and the P is 2. So, you know, in the sense, those are your repeated item. But again, this is what we have, or this is what you probably encounter over the weekend if you did the homework already. If you have not did the homework, this is what the problem that you will encounter. Question with this thing here. Question on how I have the answer or how I got how to use your calculator.